So, what is Inventor? Well, this may seem like an obvious question. It's a 3D CAD tool, right? Well, that's true, but there are a few things you need to know that make it different than other systems you may have used in the past, like AutoCAD. Inventor is a parametric, feature-based system that allows you to create 3D parts, assemblies, and 2D drawings. Parametric modeling is a bit different than AutoCAD, which is object-driven. What I mean is, in a parametric modeler, everything is controlled by either parameters, dimensions, or relationships. For example, if you want to move the position of a hole that's in a block, in a parametric system, you would change the dimension or relation that controls its position. While both systems do get the same job done, there is a reason why a lot of CAD users have switched over to parametric modeling. You actually get much more power and flexibility when using the parametric system. The parameters and relationships you set up allow you to have control over something called design intent. The term design intent basically describes the way your design will behave depending on the way you use parameters, such as dimensions and relationships, to design it. Here's an example. I'd like to center this circle within the rectangle. I know the rectangle is 4 inches by 6 inches. One way to center the circle is to dimension it 2 inches from one edge and 3 inches from the other edge. That centers the circle on this rectangle. But does this capture my design intent? Well, let's see what happens when I change the size of the rectangle to 7 inches by 8 inches. As you can see, the circle is no longer centered. So no, this doesn't capture my design intent. So how can I center this hole so that no matter what size the rectangle is, the circle will always be centered? In a parametric modeler, it's also possible to use relationships. Let's get rid of these dimensions. To create a relationship that centers the circle, I'll use something called constraints. But don't worry, all of these concepts are covered in detail in the upcoming lessons. Once the constraints are added, no matter what the size of the rectangle, the circle will always be centered. This is just one example of the countless ways to capture your design intent when modeling in 3D. As I mentioned, we'll talk much more about design intent and these geometric relationships throughout the course. You can see how modeling in a parametric environment can be very powerful. The other big advantage of this type of system is that you also get something called associativity between your parts, assemblies, and drawings. Meaning, if you make a change to the design of a part, the change will take effect in any assemblies that it's a part of, and its 2D drawing will update automatically as well. This associative behavior saves you lots of time when you make design changes, so that you only have to make the change once and all associated items will automatically update.